What is a chemical engineer? You probably have heard a definition like a person who applies their knowledge of math, physics, and chemistry to design products, processes, and solve problems. And you may be thinking, yeah, okay, but what exactly does that mean? Chemical engineering is everywhere around us in so many different industries. For example, oil and gas, chemical plants, medicine, food, makeup, electronics, and so much more. In fact, if you make coffee every morning, that means you have practiced chemical engineering. Brewing coffee is as simple as chemical engineering can get. It uses the same principles and ideas that chemical engineers use in large chemical plants. Consider all of the different ways to make coffee. They all start with the same roasting grounds you buy from the store. So why is there a huge difference in coffee made from traditional coffee maker to a French press to espresso? And the answer is chemical engineering. So let's first consider the basics and what is really happening when we brew coffee. Every time you make a coffee, you need two things, water and coffee grounds. So let's consider this simplified reaction. When the water passes through the coffee grounds, it pulls out a ton of stuff from the grounds, and the water with the extracted compounds is coffee. In chemistry, this is considered a solid liquid extraction. This stuff that is extracted from the coffee contributes to flavor. There's caffeine, which contributes to bitter flavor, acids, which taste sour, natural sugars, which are sweet, and aromatic compounds that contribute to smell and floral tastes. Depending on who you are, you may want your coffee to be really strong, really flavorful, or you need as much caffeine as you can get. And that's where the engineering comes into play. Consider yourself a chemical engineer with different tools in your toolbox: a filter, pressure, and temperature. And using these different tools alone and in combination result in different strength, time, and flavor coffee. So let's first consider the cold brew coffee. And the tools we'll be using is a filter, and the time that it takes is 12 to 24 hours. So this is how it works. You grind coffee beans finely and just put them in a jar. Then you add cold water to the jar and stir the mixture and then place it in the fridge for 15 to 24 hours. Then you take it out of the fridge, filter the grounds, and serve. And this is what you get. Cold brew coffee has more floral and sweet flavors and less bitter flavors. This is because at low temperatures, acids are extremely difficult to extract from the grounds. Cold brew is attractive to people because it is half the acid content than hot coffee. And due to this, sweeter aromatic flavors dominate in the cold brew. There's more caffeine in cold brew compared to the traditional hot coffee because the brewing time is so long, and over long periods of time, more and more caffeine will be extracted. The brewing time takes forever because at low temperatures, the rate of extraction is slowed dramatically in order to get a similar concentration coffee as traditional hot coffee.
Next is the French press style, where your tools are temperature and your time is 4 to 6 minutes. First, you grind coffee beans and pour it into the French press container. You boil water, let it sit for 1 minute, and then pour it in a container with the coffee grounds. You stir the mixture vigorously and let it steep for about 4 to 6 minutes. Then you press the plunger to hold back the grounds while pouring coffee out to serve. What you get and why. French press style coffee gives a very strong flavor. Aromatic compounds, caffeine, natural sugars, and acids are present. At high temperatures and without a filter, all compounds within coffee grounds are extracted and brought to your mouth. French press, however, does contain the least amount of caffeine than any other method because there is a short brew time and caffeine caps out in concentration due to saturation limits of the volume of water. People opt for the French press style due to its versatility. Coffee connoisseurs do not. Then there's the drip method, where your tools are temperature and a filter, and your time is 2 to 3 minutes. This is the most common type of coffee maker, and you probably have one of these in your house in the style of a Keurig or a coffee pot. For these coffee makers, you place a coffee filter in the filter basket and pour ground coffee into the filter. Then there is a separate reservoir you fill with water. You then press the brew button, which heats the water and pours it over the grounds through the filter. What you get and why. Drip coffee makers are similar to French press, but adding a filter. The filter prevents acids and aromatic compounds from passing through to your cup of coffee. This results in a weaker or more bland tasting cup of coffee. The weakness of the coffee also comes from less direct contact between water and coffee grounds. Most people opt for this option purely out of convenience. The last process is making espresso, where your tools are temperature, pressure, and a filter, and your time is about 20 seconds. You've probably seen fancy espresso machines at cafes. Espresso is extremely concentrated coffee and is often taken in drinks with heavy cream, such as lattes and cappuccinos. The main process of espresso machines is passing steam at 200 degrees Fahrenheit through a chamber of tightly packed grounds and a filter, and then into your cup. What you get and why. The result of this process is extremely concentrated coffee per volume, with a very strong flavor without the bitterness. One 2-ounce espresso shot has the same caffeine content as an 8-ounce coffee. That's 4 times the concentration. Even though a filter is used, the increased pressure extracts extra compounds out of the coffee grounds, allowing more aromatic compounds to end up in your cup. An increase in the fruity and aromatic compounds overrides any bitter taste from caffeine or acids.
Now that you know how to engineer your coffee to fit your tastes, imagine your toolbox at a larger scale. Separations is an extremely common process in industry. Chemical engineers are responsible for using their tools, which are called variables in processes, or things that can be changed such as temperature and pressure. Chemical engineers find the best ways to change these variables using math, physics, and chemistry. Why would we care to alter processes? Well, just like you wanted to alter coffee brewing to make it taste better or to get more caffeine out of it, engineers care about altering processes to increase overall sustainability. This includes altering processes to reduce waste and energy, to increase economy by making more product per day or by making it cheaper, and to make processes safer or increase overall health. Altering processes at large scale impacts everything we experience, from the things we buy at the store to our health and environment around us. That's why it's important to study engineering, so we can keep increasing the quality of how we live.